with our new textbook, and I thought I'd start with our Chapter 3 homework. And if you were trying to work on the first problem, you would need to be familiar with exponential smoothing with a trend, and MAD, or mean absolute deviation, and then make a decision about which forecast is going to be the best. So I thought we'd start back with just a quick review of the PowerPoints that were provided with the text that talks about what exponential smoothing is. So you can see it's a weighted average method, which includes all past data in the forecasting calculation. Because you're using an alpha coefficient, you're weighting, the most recent results are weighted more heavily, and it's the most used of all forecasting techniques. Okay, so all integral part of computerized forecasting, and it's well accepted for 6 reasons. Okay, and you can see the 6 reasons. It's surprisingly accurate, relatively easy to compute. The user can understand it, little computations required, computer storage requirements are small, and tests for accuracy are easy to compute. Okay, so our formula for exponential smoothing, just the basic formula, says that we're going to take the forecast from the last period, which is forecast for t minus 1, and I should say the t represents the forecast for the time period that we are trying to forecast. Okay, so the t is the time period that we're currently forecasting. So t minus 1 is the time period just before that. So as an example, if I were trying to forecast for July, right, which would be the 7th month, then the t minus 1 would be the 6th month, or June, right? And it works the same way if you're talking about weeks or days. You just subtract 1 from where you're at for that particular time period. Okay, and the A represents what was the actual demand for the t minus 1, or the most recent time period, and the F then again is the forecast for that time period. So if we were using July for an example, right, if we were trying to forecast July, we'd be using the forecast that we had for June plus the alpha coefficient times the actual demand that we had in June less the forecast for what we had in June. Okay, so relatively straightforward once you're familiar with what the terms represent. Okay, so you'll be on an exam, you'll be provided the formula, but you'll need to know what the terms represent. Okay, so then they show us an example, and basically if we were going to try to forecast for time period 2, right? So if I'm putting together a forecast for time period 2, I'm going to say it's going to be my forecast from the previous time period, which was 820, plus my alpha, which we're going to use a 0.2 alpha, times the actual from that previous time period minus the forecast. So it becomes 820 plus 0.2 times 820 minus 820. Okay, so then our forecast for time period 2 is 820. All right, so then we move on, and let's jump down here to forecast 4, because that's, when we start out, we don't have much information, and our demand and forecast are typically the same for that first time period. Okay, for time period 4, we're going to take the forecast from time period 3, which was 811 units, plus our alpha coefficient of 0.2 times the difference between the actual for the previous time period. So the actual was 680 minus 811 was that forecast, right? And then that's how we're going to get our forecast of 785. And you can, again, pull up the slide and review it and go through the examples that are listed here, okay? Then the next thing we can do, though, that works relatively well if there's no ongoing trend, right? And so the presence of a trend causes the exponential smoothing forecast to always lag behind the actual data. So if you're on overall, if you have a growth trend, right, you're always going to be under predicting and with exponential smoothing unless you adjust for that trend. Okay, and so we can adjust that by adding a trend smoothing constant, which we call delta. Okay, and so our text shows us that what we do is we take our forecast that we have that we call fit, and we call it fit because it's a forecast including a trend, okay, and that forecast including the trend is going to be your basic forecast plus the trend factor. Okay, so we're going to walk through how we would actually calculate this. Okay, and basically our text tells us that there are 3 steps, right? The first one is that we calculate the forecast without a trend, then we calculate the trend factor, and then we add the forecast without a trend with the forecast with the trend factor. Okay? All right. So F sub t, exponentially smooth forecast for time period t. T sub t, exponentially smooth trend for that time period. Fit sub t is the forecast including the trend for time period t, and fit of t minus 1 is the forecast including trend for the previous period. Again, and the rest of that is still the same as what we had before. A sub t minus 1 is actual occurrence for the previous period. Alpha is the smoothing constant, and delta is the smoothing constant for the trend. All right? So in this example, it says calculate the new forecast assuming the following. The previous forecast including trend is 110, and the previous estimate of the trend is 10. Okay? Our alpha coefficient is 0.2, and our delta smoothing constant is 0.3. Okay? Actual demand for period t minus 1 was 115. So we start out in step 1. We calculate our forecast without including the trend factor. So we use our forecast from the previous time period plus our alpha coefficient times the actual demand from the previous time period minus our forecast from the previous time period. So it's 110 plus 0.2 times 115 minus 110 equals 111. Okay? If we finish that math out. I think it can be a little confusing because we say calculate the forecast without including the trend, but then when we see the equation, we're using the forecast including the trend from the previous time period. But make that distinction that that's our forecast from that previous time period, but we'll have to do an adjustment for the trend, okay? And so this is basically forecast without including the adjustment for the trend. We calculate the trend, and then we make that adjustment, okay? When we calculate what our trend factor is, it's the trend from the previous time period plus the delta, that smoothing coefficient, times the forecast from the previous time period minus, plus the delta times the forecast for the current time period minus the forecast from the previous time period. So we're going to have 10 plus 0.3 times 111 minus 110 gives us a trend factor of 10.3. Okay, and so then we're going to add those together. So our forecast including trend for this time period is our current forecast without trend, which was 111, plus our trend factor, which was 10.3, which gives us a forecast including trend for this time period of 121.3. Okay, so that's all, follow along on the slide and you can see that. But what I thought we'd do is I'll go ahead and we'll open up we'll look at McGraw-Hill Connect, and we'll look at that first problem and walk through what we've got there. Okay, so these are algorithmic problems. We're going to go to McGraw-Hill McGraw-Hill Connect, and we're going to work a problem that's like your homework problem. All right, and so typically what I do is I go ahead and just copy this information from here, right, into Excel. So I'm going to open, I've got an Excel book here, and I'm just going to paste the information into Excel. And I'm going to format these as numbers just to make sure that it works for me. Format cells number, and we want 2 decimal places. Okay. And the first thing that we're going to do is it asks us to calculate the single exponential smoothing forecast for these data using an alpha of 0.3. So I'm going to just indicate here that my alpha is 0.3, so I can keep track of that, okay? And that this is my exponential smoothing. And it's just the basic exponential smoothing. We're not taking into account any trend yet, okay? So I'm going to wrap this text and center it, okay? And then I also want this to be, let's just go ahead and format it the same. So we're going to format that the same, all right? And if I look to my problem, it says calculate the single exponential smoothing forecast for these data using an alpha of 0.3 and an initial forecast for time period 1 of 34.00. Okay, so there's my first forecast. My second forecast then uses the exponential smoothing formula that says that I'm going to take the previous time period's forecast and I'm going to add to that my alpha times the difference between the actual from the previous time period and the forecast from the previous time period, right? And, so there. And that tells me then that my forecast for time period 2 is 34.00. Okay, let's just do that again. So for exponential smoothing, I'm going to take the forecast from the previous time period, which is 34, and I'm going to add to that my alpha coefficient times the difference between the actual from the previous time period and the forecast from the previous time period. Okay, and so then that's 34.9. And what I'll do then is I'll just copy that formula all the way down. And you can see 34.63, 34.74, 35.72, 35.80, 36.76, 37.43, and 38.5. So we're right on the money with that. Okay. The second part of this asks us to use exponential smoothing with a trend. Okay, so I'm going to go ahead and open that spreadsheet again, and we're going to do exponential smoothing with a trend. And if you remember, to do exponential smoothing with a trend, we basically have 3 steps that we're going to need to do. One is we need to calculate the initial forecast without trend. So I'm just going to go without trend, right? And we want to wrap that text and center it. And then we need to calculate the trend. Okay, and in this case it tells us that calculate the exponential smoothing with trend factor, with the trend forecast for these data, including an alpha of 0.3, so that remains the same, and a delta of 0.3. So I'm going to just put in here that our delta is 0.3, so I can keep track of that, and that an exponentially smooth forecast for that first time period of 33. Okay, and an initial trend factor of 1.00. Okay, then here we have to have our forecast including trend. Okay, and if you remember, that's going to be just our forecast without trend plus our trend factor. All right, let's move on to the second time period. Okay, in the second time period, we take our forecast. So to calculate just the basic exponential smoothing, we're going to take our forecast from the previous time period, which was 34. We're going to add to that our alpha coefficient of 0.3 multiplied by the difference between our actual, which was 34, right, less what we forecasted, which was also 34. Okay, so our forecast without trend is going to be 34. Okay. Our delta, or excuse me, our trend factor is going to be our trend from the previous time period plus our delta of 0.3 times the difference between the forecast for this time period, so it's for this time period, minus the forecast including trend from the last time period. Okay, and so then our forecast is going to be 34 plus 1, which is going to be 35. And again, let's make all of these be 2 decimal points. Okay, and so if we look, time period forecast including trend for time period 1 is 34. Forecast for including trend for time period 2 is 35, and we can just continue that on down. So let me do one more example, and then we'll just copy and paste the formula. Okay, so what we've got is we need to calculate again when we're doing exponential smoothing with a trend. We need to calculate the forecast without the trend. We need to calculate the trend factor, and then we need to add those two together. So when I calculate it without the trend, it's going to be the forecast from the previous time period plus alpha of 0.3 times the actual demand from that time period minus the forecast from that time period. So our forecast without trend would be 35.6. Our trend factor then is going to be our trend factor from the previous time period plus our delta, which is 0.3, times the difference between our current period's forecast and our previous period's forecast, which included the trend. Okay, and when I add those two together, it gives me 36.78. Okay, and so you can see how that works itself out, and what I'm going to do is I'm just going to go ahead and copy those down, right, and we'll just check our answers real quick. 36.78, 36.88, 37.07, which still work, 38.20, 38.18, 39.15, 39.81, and 40.98. So you can see that those are all going to work for us. Okay, so that's how we calculate exponential smoothing, right? That's what we did here, is just our basic exponential smoothing, and then here we did our exponential smoothing forecast with a trend. The next thing that we're asked to do is, it says calculate the mean absolute deviation for the last 9 months of the forecast. Round your answer to 2 decimal points. Okay, well this is really straightforward. Okay, so what we're going to do, the last 9 months, so basically we're going to leave out month 1, and we're going to take the difference, the absolute value of the difference between actual demand and forecast. So actual demand for time period 2 was 37, and our forecast was 34, right? And we just need the absolute value of that difference. And let's again go ahead and show that as 2 decimal places. Okay? And I'm going to do another one again. It's actual value. Sorry, it's the absolute value of the difference between the actual and the forecast. Okay? And we can go ahead and just copy that down. And that gives us, again, if I format these, I'm going to format these all to be 2 decimal places. Format cells number 2, okay. And then if I want to take the average, I can go function average, and then I can just select which cells I want to highlight, which is going to be these, and that's going to tell me then that my mean absolute deviation for the exponential smoothing method without trend was 2.15. And if I'm interested in my MAD for the last 9 time periods, again, it's going to be the absolute value of a forecast including trend versus the actual demand. So I'm going to take actual demand, and I'm going to subtract out the forecast including trend, and I'm going to take that absolute value, and that's going to be 2. I'm going to format that to be a number with 2 decimal places. I'm going to copy that down, and I'm going to take the average, and again, because I can just copy and paste that average formula, and that gives me 1.33. So what that mean absolute deviation is telling me is I'm looking at the average error away from the forecast that each forecast is, in terms of, doesn't matter whether it's above or below, because I'm not accumulating positives and negatives. I'm saying that every difference, whether it be positive or negative, should count. So I'm taking that absolute deviation and I'm summing it up, and I'm saying on average I am missing the forecast by 2.15 units with the exponential smoothing, and on average I'm missing the forecast in exponential smoothing with trend by 1.33 units. So then when I'm asked to say, well, which would be best? Well, clearly it would be best if we were missing the forecast on average by the lower number of units. Okay, so that should be enough to help you get through that first problem and look at exponential smoothing with trend, and mean absolute deviation. Hope that helps.